Some other language we want to talk about, or definitions we need to be at least a little familiar with, is sampling, random samples. As we get into statistics, there's a lot of value and power in random sampling. You may hear the term a simple random sample, and you can think of a simple random sample is, what makes something a simple random sample is if each sample of the same size from the same population has the same, this is the technical definition. Every sample of the same size from the same population has the same probability of being drawn. In essence, that's basically saying everyone in the population has an equal chance of ending up in your sample. So if I was trying to collect a simple random sample of college students and I just hung out at the gym, it's probably not going to, every possible sample isn't going to be equally likely to end up in my study. Question?
But would something like jury duty be an example of a simple random sample? Like voting age individuals in a given place have the same
That's
ish?
Probably in theory.
In theory, okay. Yeah.
I mean, there's ways to come up, there's good ways and bad ways to try to get simple random samples. The key is how do you come up with a way that everyone has an equal possibility of getting in the study. I mean, one way, if I wanted to create a sample of college students, hanging out in front of the gym may not be a good way. Can you think of ways that I could, where every student might have the same chance of ending up in my sample? Can you think of strategies you might do?
Library, stand on the mall.
You could stand on the mall, that's probably a little better.
Go to the registrar or whomever has the list of all students in the student population.
That's what I would do. That's what I would do. Go to the registrar and ask for a random sample of, get every name, every email address that the student has, and put them into a random number generator and pick kids out that way. That would probably be pretty good.
I guess the question I have about that is the problem with those is when you randomly sample them, if it's a group like your students that you have some control over, but when you do a random sample with other people, there's only a certain percentage that even respond,
right.
And then it's no longer random because there are people who respond and people who don't.
Oh, that's now we're kind of getting into there's a whole nother conversation in terms of research design that's not for this class. But yes, absolutely. Sample responses to one of the biggest challenges creating simple random samples is how do you get participation? How do you get people that are willing to, out of the blue, potentially respond? Surveys, you do anonymous cold call surveys. I think the last number I can remember seeing, you'd expect about 3%.
And even at this point, it's so, I think about, when we're looking at the polling data politically, I'll come back to that. No one answers their cell phone, so the people who do answer their cell phone, that's a whole different demographic.
Yeah.
I was just looking at a survey on Bangor Daily News. It's like, how can they be getting that number? But then people are finding they couldn't do the survey on their cell phone. So that totally skews what you have as the results. Like, if you can only do it on a laptop, then you're only getting a certain demographic to begin with so that's skewing everything.
There's a whole interesting, if we have some time, one of these days, maybe, let me think about it. No, for the whole, you look at the 2016 election was awesome.
Statistic people,
It was incredible. It was a once in a lifetime event to sit there. I was in California. I did vote absentee. We were out in California, and between the time we were in San Jose driving to the San Francisco airport, you just saw it was from 95% chance Hillary was going to win to the 95% she was not going to win over a few hours. Actually, I've got, maybe there's a video I
Oh,
can
we remember.
show you guys. But
Don't
no, it was
worry.
incredible.
We're reliving it.
Yes, we're watching
It was,
every day.
and we're like sitting on the plane as
Texting our friends.
as they're saying, as the thing's closing, the door's closing, they're saying turn off your computers as they call the election. It was,
Oh.
wow, it was
It's
exciting.
not helping our stress level.
It was exciting. The oh yeah. What's interesting is understanding, because the polls were so incredibly wrong,
Yeah.
and why.
Yeah.
And there's a lot of issues why. And it came shortly after the Brexit vote. Another case where the polls were not quite as incredibly wrong, but
still pretty
very wrong.
Yeah.
That was actually kind of exciting too. We were watching that in Canada on a vacation. There's reasons for that. There's very interesting reasons on people where people don't understand polls, and there's problems with how polls are often done and how pollsters do it. And one of the things that came up with Brexit, it was certainly also going on here, I think. But there's other factors. But one, they'll shape. Well, you come up with, because you run into these issues of getting participation, and you want to structure your sample. Maybe the people responding don't look like what you think the actual voters are going to be, so they leave the idea of a simple random sample and start to do other approaches. The systematic sampling is not a random sample. But when I was an undergrad, I was involved in some systematic sampling as part of the course, and doing an election, and it was by a professor whose lab was notoriously accurate compared to all the big expensive surveys for the state. They were very reliable, did a very good job. They did systematic sampling. And what they would do is, because you would the day of the election, you'd stand out in front of the polling place, and you would have a counter. And I still remember my number. It was 21. Every 21st person leaving the polling station, I would survey. And it's not quite simple random sampling, but it's close in terms of kind of how are people voting that day. So by the end of the day, they had a very good estimate of exactly what was going on, which is kind of interesting. But there's other ways. Now I'm digressing. But it is fascinating. So people will structure you'll see pollsters will start to rig their samples. Oh, I think, and some of it, one of the things that came up particularly in Brexit, but I think it happened here as well, is, well, the other polls are saying that the no's going to win. I'm polling, and my poll seems to say Brexit's going to pass. Well, I don't want to stick my neck out.
Right.
So I'm going to restructure. Maybe there will be more Labour Party people voting than I think. So I'm going to go out there and sample Labour. Here, it's part of what happened is same sort of thing. Okay, I'm going to guess what I think what's going to happen. Oh, Hillary's up. Oh, there's going to be a huge turnout of women. So I'm going to not do a random sample. I'm going to structure my sample and make sure I get more women than I normally would have. And maybe I'll get more Democrats than I normally would have, because I think they're really going to be charged. And in 2012, the Democrats really came out because of Obama. I think we're going to... And so they'd start to manipulate their samples to reflect what they thought was going to be the turnout. And the more you leave it, the more... if you're right, it's good. If you're wrong, it can be disastrous. There's also issues, too, in terms of the trajectories. Keep in mind, when they call up in the next month and ask, who are you going to vote for? That's not who you're going to vote for.
No.
It's not who it's going to... No, they're not assessing who... They're assessing who... People who answer the phone and are willing to tell them who they're thinking they might vote for right now.
Right.
It's a the trajectory, and you see some kind of try to look at the trajectories are a big deal in terms of if you see things going up or going down. These are snapshots, and then there's a whole other issue of kind of how much, because it's like from a statistical perspective, the margin of errors, which we'll talk about later. There's no way, if you just look at it, the confidence in those plus or minus threes, there's no way things could be that right and the stats be wrong. But there's a whole dimension to the random sampling that everyone often overlooks. That now there's some people that talked about it years ago, kind of like all high-fiving each other, because there's been talk about these confidence intervals when they're talking about plus or minus 3 or nowhere. It's much larger than those because of things like this. Anyway, I digress. Let's get back to this. But you can see kind of how exciting. Oh. Once in a lifetime. It was incredible to just see. It is, wow.
If you can watch it as a neutral observer.
Oh, I can. As a statistician. Oh, I think there was
It's terrifying.
Jeez.
enough politics. So systematic sampling.
Interesting.
Systematic sampling is not a random sample, but a good alternative. And that's where, like I said, I was sampling every 21st person that came out of the polling station. Or you might sample every nth person leaving the Magic Kingdom. You know, if you would go, I've been actually hit a number of times over the years, and they ask you to do a little survey.
I'm gonna
That's a
digress
good.
things. I don't think people are gonna answer even coming out of the polling station, but.
Oh no! It's right, because we'd regularly get people blowing you off. But it's better. It's closer to a random sample than trying to artificially create what you think at least this is my bias. It may be difficult to do that if you don't have an army of undergraduate students that can run around the state for a few points of extra credit for you.
You're at least getting people who have actually voted.
Yeah.
You know, the rest of it is you don't even know if the people you're voting are going to
Yeah.
like get a cold that day and stay home or whatever. You know?
Well, and then there's all sorts of issues. Well, anyway.